Good afternoon, everybody. Welcome to Chem 170 with your host, me, Dr. White. And I thought I'd start out the class with something a little fun for you. At least I hope it is, because later on you got to take my test. You can all give me nasty looks now. But where did I hide it? Ah, thought I'd share something with you. A friend of mine whose wife teaches, I'm friendly with both of them. My best friend, actually, Neil in Fort Wayne, sent me this over the weekend. I didn't have time to do it on Monday, but I thought you'd all get a chuckle out of this when I saw it. Oh, yeah. And so you can all have a chuckle. If anybody wants a copy of this, please feel free to uh, send me an email and I'll attach it right back. If you want this, it's a JPEG. And by the way, the other thing that when I look at that, the woman in there reminds me a lot of my grandmother, who I thought the world of. Probably the finest person I've ever met in my life was Grandma Greenman. And she was tough as nails and had a sense of humor that you have to watch out for, which I think I got from her. So, anyways, I thought you'd enjoy this. All right. Now, I'd finished up on Monday talking about alcohols or phenols really as antioxidants. This will not be on test. Switch was off, click. And I talked about how they work briefly and how BHA and BHT used to be in potato chips, which is why I like antioxidants, because I love potato chips. Lay's onion and sour cream are just dangerous beyond dangerous. I can open a big bag of that and it seems to evaporate within an hour or so. It's that dangerous. I only buy it a couple times a year because I know I'll get 2 bags and they'll be gone. Anyways, now switches now, click on, and it's time to talk about another area. And I better warn you, this area I'm going to talk about stinks, but at the same time, I'm going to have to tell you a very sad story. True story, sad story. So what's this area? It's a new functional group. And that new functional group is a thiol. Now, thiols are sulfur analogs of alcohols. And that's where instead of an OH group, you have an SH group. And therefore, I hope I'm not having a bad writing day, tablet writing day. Let's try it again. That's better. Here we have an alcohol, and a thiol is where you replace the oxygen with a sulfur. And these are called thiols. Now, they used to be called mercaptans until about 15, 20 years ago, maybe not even that long. I'm not sure exactly when Iupac changed, but the old name was mercaptans, which is what I grew up in. So if you hear me say the word mercaptan, it's really a thiol. Now, thiols have nomenclature similar to alcohols, but instead of a OL ending, you use THI, which is how we use sulfur, and OL tells you it's like an alcohol. This will not be on a test. And the most important thing I can tell you about them is they stink. Now, I'm going to slip a slide. What's the stinkiest thing you can think of? Skunks. If you've ever been around where a skunk let loose, guess what? It stinks. Now, somebody, and I'm glad it wasn't me, analyzed what's in the spray or defensive weapon a skunk uses. And they found this thiol, notice carbon R, SH, is about 45%. Because it's got a double bond conjugated with the sulfur, it make it even stinkier. And then 25% is this thiol, R group SH. And the remainder, I assume, is water. And it's quite stinky, real stinky. By the way, the best way to get rid of thiol skunk odor is use an oxidizing agent like very mild potassium permanganate, because it oxidizes, unlike oxygen, this can oxidize to what's called a sulfone, which I will not be teaching you, which doesn't stink as much. And if your dog or cat ever gets skunked, ask your vet, is it all right to use something like dilute potassium permanganate? A lot of vets don't do that. Sometimes you'll hear people say, well, you use bleach. I wouldn't put that on any dog or cat, but bleach is also an oxidizing agent. Now, important thing, and I'm going to tell you a story about it, but T-butyl thiol, you know what a T-butyl group is, I hope for today when you take the test. And this is a common name, not a Iupac name, just like we have common names for alcohols. And this is put into natural gas, methane. Methane has no odor. Now, the other place you can find thiols are in onions and garlic. Now, I have to admit, Dr. White loves onions and garlic, and my father did too, and my uncles. I wonder where I got that. And one of the delicacies, and hang on to your chairs or wherever you are sitting, that my uncles and father loved, and I learned to love, even though I don't eat it anymore that often, is onion and Schmaltz sandwich. What's that? Well, first of all, you take some good bread, and challah, if you don't know what challah is, the best bread, and you can get that at all Jewish bakeries. And then you put Schmaltz on that. What's Schmaltz? That's rendered chicken fat. So instead of butter, this is even more, I should say, higher in cholesterol. And if it's done made properly, it's got a nice taste to it. And then you slice some raw onions and put the other piece of bread on top, and that's an onion and Schmaltz sandwich. By the way, when you eat that, prepare not to go out for a while because your breath is going to stink, but oh, it's so good. All right. But anyways, natural gas has no odor. But you're going to say, Dr. White, I can smell if there's a gas leak, and that's because they put in T-butyl thiol. And it's time for me to tell you an important story you should know. Hint, you should remember this story. All right, in Texas, and there's two versions, and the ending is still the same. Back about 1935 in this high school, they had a terrific explosion. And it killed about 150 students and teachers and badly burned a lot more. And the reason was, it was a natural gas explosion. And you're going to say, Dr. White, how come they didn't smell it? Well, back in 1935, they didn't put in T-butyl thiol. And there's two versions. One version is there was a social at the high school, a chili social. It's Texas, what do you expect? And whoever was making the chili in the kitchen off the gymnasium where all the people were and students went there and forgot to watch it. The flame went out, filled the room with natural gas and either a lit cigarette or what you don't know, because I work with hydrogen, your light switches in your house, when you go like that, turn it on, there's a little spark in there. If there's anything explosive around it, boom, it goes up. That's one version. The other version is when they built the high school, they weren't too careful when they put the pipes together for the natural gas. Plus, they were getting it free from an oil company, had oil wells next to their high school. So it leaked and eventually filled enough gas in the high school that when somebody turned on a switch, or the one story is in the area where it leaked the most, where they're doing woodworking, they used a drill, turned on a drill press or whatever, that sparked, boom. Because of that, the Texas legislature had a commission, and that commission was empowered to investigate what happened and how to make sure it never happened again. And what they found was you couldn't smell methane, and they came up with a great idea, and it is a great idea because it saves lives, that adds something stinky there. So if there's a leak, you can smell it. And what they found was T-butyl mercaptan. Now it's a thiol. See, I used the old name. Like I said, I will. But T-butyl thiol stinks. How stinky is it? How many of you have smelled a gas leak? Raise your hand. You know, it stinks pretty good, real quick. They only put 1 pound of T-butyl thiol, I got it right that time, in 1 billion pounds of methane to get that stink. There's only 1 to 4 ppb, parts per billion. Now, do I have time? Oh, I do. Back when I was in grad school, I went to Michigan State, and the Michigan State chemistry building was huge. It was almost 2 blocks long. This is the chemistry building, nothing else in there. It was 5 stories high. It had a basement that was as long, a sub-basement, and a sub-sub-basement. They also had a smaller penthouse to do certain chemistry that was quite dangerous, and you went on the roof literally to do it. Well, anyways, one day in November, late November, fire alarm went off in a chemistry building. You leave quick. And we would have every month an unannounced drill. And usually you go out, they'd evacuate everybody out the building. Then about 5-6 minutes later, you get the oil cleared and go in. Well, this was November and it was cold outside, and I was in my lab, luckily. So I grabbed my coat, whatever, everybody else, and we went outside. And if you're not familiar with chemistry departments, especially large ones like Michigan State, you have different grad students, the organic, inorganic, P-Chem, physical chem, and analytical. And we all group together and we're talking 5 minutes, 10 minutes, 15 minutes. Finally, I or one of the other grad students in the organic, fireman was walking by because the fire department was there, and asked, "What's wrong?" And the fireman, gas leak. And after he left, and I can't remember if it was me or another grad student, I think it was someone else, said, "All right, what idiot poured T-butyl mercaptan thiol," back then it was mercaptan still, "down the drain?" It turned out some stupid grad student in organic poured it down the drain. It went all the way to sub-basement. One of the water traps for the drains down there had dried out. And a janitor walked by and smelled the T-butyl thiol. Oh, I got it right that time. Gas leak, and called the fire department, which is the right thing to do. And so the sad story is, due to the deaths and injuries in that horrific explosion and fire in Texas, we now are safer because they add T-butyl thiol. And that's it. We're done with thiols. But the next time you smell one, guess what? It's to save your life from gas, unless it's a skunk. Now, one person last spring pointed out, because they worked in a hardware store, in propane that you buy for your barbecue, it smells different. And I looked it up, and turns out they put a different thiol that was T-butyl thiol, soluble or in methane, natural gas, but not that well soluble in propane. And so they use another thiol to make it stink too. There's no problem set on thiols other than you should know, 1, they stink, and 2-T-butyl thiols put into natural gas so you can smell it and protect you. All right, it's new chapter time, new functional group time. And we get to go to a new chapter. And that new chapter, everybody see ethers and epoxides on your screen? Thank you. I apologize, but sometimes Zoom tells me, and it's a problem, a fault with their interface. This is what's on the screen. I see it, but you don't, which is why I developed my thumbs up, people. All right, this new chapter, ethers and epoxides. And you won't believe what I'm going to get into in this chapter. Dr. White's going to have some fun. I'm going to talk about the Civil War. I'm going to talk about an unfortunate oil well spill. And I'm going to talk about something you'd never, ever think would be discussed in this class, but it's organic chemistry. So we got exciting things coming up. So let's get to it. Now, the first new functional group is an ether. And an ether is an alcohol where you replace the hydrogen with carbons. So ether is this functional group, and it has carbons on oxygen, the other side carbons. Notice the R prime here. That means this group on the left can be the same or different than the group on the right. And this is an ether. Now, instead of teaching the Iupac ethers nomenclature, which most people never use, I'm just going to ask you to learn the common name for ethers. And it's real simple. Name each R group of the ether as an alkyl group and add the word ether at the end of the name. Seaboard, for example. Ooh, I got to get to work. So for common name, an ether, and remember, this is an ether. And you name each R group, R and R prime, as an alkyl group, and then you add the word ether at the end. So I better get to work because it says seaboard for examples. All right, on your screen, you should see a structure, and let me get my thumbs up, people. You see a structure on your screen? Thank you. All right. Now, what is it? Well, you look for what's different. Ooh, an oxygen. It's got carbons here and carbons here, and they're different. And this is what it is. And that's an ether. How do you name it? Well, what's this if this were an R group? It's a methyl group. What's this if this were an R group on a ring or a long chain? N-propyl. And since it's an ether, I'm going to pop the word ether at the end. And that's how you do it. Now, since there are no rules for this, it's common name. Common names don't have official rules. If you would put N-propyl methyl ether, it's the same thing. Not hard. Well, let you try one. And why don't you try what's the common name for this compound? Oh, one thing I forgot to mention, we're only going to go till about, let's see, 2:45, 2:45. And because we're going to have a lab today, it's a real quick lab. And after that, I'd mentioned in my email, I'd send out the password for test number 1, which you'll take today, and please upload by tomorrow, or you can take tomorrow morning if you want. It's up to you. I'm going to send it out a little earlier. Also, I've been holding my fingers. Twice today, I've lost internet service. I think they had some bad equipment last week, 2 weeks ago, I think it was, they had some trouble too. But so far, so good. All right, looks like everybody's done. Let me get to work. And we look at this and say, what functional group is that? You look for what's different. What's not carbon, what's not hydrogen. Oh, look, an oxygen. And on this side, I have carbons. This side, I have carbons. Doesn't matter which side you call prime. And this is an ether. And how do you name this ether? Well, you name each R group as an alkyl group. This is isopropyl, this is methyl. Well, I could have put this one. These are awful P's. Hold on. You call it isopropyl methyl ether. I have a bad habit of capitalizing when I'm writing the P's in propyl, but they're all lowercase. But if you do either way, I don't care on a test. And you could also call it methyl isopropyl ether. Either way. Oh, let's do one more. These are fun. That's better. Again, what's the common name for this structure? Sorry about the delay. I was just looking for something. All right, someone just, JC just asked a question, or a while ago asked a question. So it takes time to scan things. Do we have scan and turn our test? Well, yeah, you have to get it in by 10 tomorrow. I've given you plenty of time. You know, when I say take an hour, if you take a few more minutes, I'm not going to tell. If you don't tell, just don't cheat, and that'll be in the email I send out. Any form of cheating is cheating, and I take it seriously. But figure the actual time to actually write the test if you were in a classroom should take you about 40 minutes. And I say, take an hour. If you got to need an extra 5 minutes or so, go ahead. Either you know it or you don't. And then tack on the extra time to scan it and send it to me. I know some instructors, they have, yes, you have 60 minutes to take the test, and you got to do all that unless it's online, and those are multiple choice, which Dr. White doesn't like. You're welcome, Jason. All right, let me try and get the right screen up again. All right, there it goes. It was burping on me. All right, everybody, since I was just having trouble, does everybody see the ether on the screen? Good. And I think I know why I'm having trouble. Hang in there for a second. Nope, I'm signed out. I thought, anyways, let's look at this. And the question is, what's the common name for this molecule? Look for what's different. Here we have, oxygen. Carbons here, carbons here. What do we have? An ether. What alkyl group is that? Ethyl. Wait a second, on this side, same thing, ethyl. How do we say two of something? Di, and then ethyl, because there are two ethyl groups, and it's an ether. So this is diethyl ether. And this is probably the most widely used and famous ethers of all the ethers. Why? Well, let me tell you why. Back about 1840, right before the American Civil War, they found that diethyl ether, if you inhale it, knocks you out like that. And that was the first inhalation anesthetic. And in the Civil War, it was used, unfortunately, a lot because there are a lot of casualties from the Civil War. Sad but true. Now, there's one problem with small ethers or most ethers is they are more flammable than gasoline. Handling. Angela, however you can hook in, that's fine by me. You have nothing to apologize for. I had trouble earlier with my internet, and thank goodness I'm here. All right, does that help out? Let me just check. You're welcome. And if you're having trouble with their phone and your email, you have until tomorrow. Hopefully it'll clear up. If not, send me an email and we'll talk about it. All right, let's get back to my story. Well, ether, one of the things is denser than air. And if you have gasoline, which is lighter than air, it spreads after it evaporates. Ether stays right here. And if you've ever seen an ether fire, they're pretty impressive in a negative way. When I was an undergrad, the lab I was in was known as the fire lab because out of 16 weeks, we had 13 fires, almost one every week. People are stupid. You don't light a match to start a Bunsen burner when the guy next to you is using ether. And you should know better. We had students who didn't. I never had a fire. But anyways, ether is so flammable. It makes gasoline look like water when you're dealing with it. Well, think about operating in the Civil War, or even into the early 1900s, 1910. Civil War, at night, you had a lantern or a candle, boom, you had a dead patient because their lungs caught on fire. Or worse, the fire also burned the hands of the surgeon. You no longer have a surgeon who can operate. And that happened even in the early 1920s. And that was because if you want to cauterize a wound with electricity, spark, fire. Well, luckily, organic chemists found a way to come up with other ethers that were less flammable. And that is where you replace some of the hydrogens with halogens like chlorine and fluorine. And that makes it much less flammable and available to modern science or medicine really as a inhalation anesthetic. Time for Dr. White's story. When I moved into the house I'm in right now, I did some stupid things, and that was because I'm not weak. I picked up 2 boxes with books. I'm sure it was at least 300 pounds and carried them upstairs. I did that more than once. And guess what? I had a problem with my hernia. I popped it. And it turned out it would have happened maybe eventually, but I helped it along. So I found a good surgeon recommended by a friend of my brother-in-law's who was a heart surgeon, a regular surgeon, but had done some heart surgery, I think, on him too. But it was just a general, one of the best surgeons in the Chicagoland area. And I went, and he said, well, I didn't know what it was at first. And I went to him, and he said, you got hernia problem, you need an operation. So guess what? I had it. Now, my doctor, I didn't know, and I'll tell you what I didn't know in a second, or I should say my surgeon. My surgery was at 1 o'clock at the Evanston Hospital. And that's where he practiced out of one of the hospitals. And since my sister lived in Skokie, I figured I'm nearby, she's nearby, that's good. I live in Schaumburg. So you get on the gurney, you know how they have you put on the gown and everything, and you're laying on the gurney. And I am outside the operating room, and I see it's 5 to 1, 1 o'clock, 5 after 1. Little keeps on going. And finally, one of the doctors, who was my anesthesiologist, came up to me and said, we're running late. And I said, what's the problem? He says, can't you see your doctor's not here? And I can't, how do I know? Everybody's wearing their masks and gowns. He said, well, he's known to be late, like always. So just hang in there. Man, by the way, what do you do? And I told him I'm an organic chemist. He said, oh, I'm your anesthesiologist. And he brought over the bottle of what they're going to use to knock me out initially. I looked at the label and I said, oh, I know the structure of that. And he said, oh, and he said, oh, I got to go to work. And I said, what happened? Can't you tell your doctor's surgeon's here? Oh, by the way, in case you were wondering, I survived. And what did they use? And let me show you. This is the molecule they use. Notice it's an ether, and it has an ethyl group and a methyl. And the methyl group, 2 of the hydrogens are substituted with fluorine. On this CH2 group, 1 of the hydrogens chlorine. On this CH3, all 3 hydrogens with fluorine. It's got the trade name isoflurane, and it works. And I live to see another day. Now, switches off for this slide. I just wanted to show you what is the Iupac nomenclature for ethers. The smaller, name the smaller alkyl group of the ether as an alkoxy group. And RO bonded to something longer is called an alkoxy group. Name the larger group as an alkane with the normal nomenclature rules. And then name and number the alkoxy group as a substituent on the larger alkyl group of the ether. And let me show you something. Why most chemists, organic chemists, like almost all of them, when you can, use common names. And again, switches off now, but I thought I'd show you something. What is this in an ether? common name. You should be able to do that. I'm going to give you a minute to think about what is the common name, then I'll write it down for that ether. All right, time's up. What do we have here? CH3 methyl group. Ooh, 4 carbons. N carbon, N-butyl. So you call this N-butyl, methyl, ether, or you could call it methyl N-butyl ether, doesn't matter. This is the common name. Iupac, and this will not be on a test, but I thought I'd show you. This whole group is called methoxy. Methyl, and then you change the YL to OXY, and it's methoxy. This is 4 carbons, so that's butane. What carbon is the methoxy group on? Give it the lowest number. So that would be 1-methoxy butane. I like the common name better. It's easier to generate. All right, there are 2 questions I can ask when it comes to nomenclature. One is, here's the molecule, give the Iupac, but for ethers will be the common name. Or I can say, here's the common name, draw the structure. And I'll ask you to draw T-butyl ethyl ether. I'm going to share some of the fun. All right, anybody need more time? Nobody's screaming at me, so let's get to work. What do we see? We always started this way, even with common names. That tells you it's an ether. Ether has the structure. What are my R and R prime? Ethyl, T-butyl. Doesn't matter which side. I can draw it this way. Remember, there's 4 bonds to carbon. Or I could have drawn it this way. Which is the right way, correct way? They both are. Once I finish. And that's how you name and draw ethers. And ethers, one of the nice things about ethers are they're excellent solvents to run reactions in. And they're also good to help remove things from other things like chemicals from water into ether. When I was a grad student, I used to go through about 3 or 4 pounds a day of ether in the research I was doing, diethyl ether. And I also used another ether. This won't be on the take a 5-member ring and substitute one of the carbons with oxygen. This is an ether, and it's called tetrahydrofuran, common name, which everybody calls CHM. And I used a lot of this daily. And that's how you name ethers. Now, as I mentioned, it switches off. They're very low boiling and they're flammable. I mean, flammable. They make gasoline look like water when you're compared to the flammability of ethers. Now, how do you make an ether? There's one main way, and it's called the Williamson ether synthesis, named after the organic chemist Williamson, who I don't know if he's American or English. One of these days I'll have to look it up. This is called an alkoxide. You make it from an alcohol reacting with sodium. This is an alkyl halide, where X, as you know, for this reaction are chlorine, bromine, or iodine. And this is called a nucleophilic substitution reaction. And this oxygen with the minus charge attacks the carbon with the halogen, dries it off, and you form an ether and a salt. Oh, by the way, if you haven't found out yet, I should tell you, organic chemists are very violent. We use terms like, instead of react, attack. And really, you look in the journals, we use that terminology. And the question would be, what's the organic product or products? And when I say what, that means you draw, and I could also say draw. And a lot of times I'll do this. And the question would be, give the organic product or products for the following reaction. 3 points each. How do you do that? You look at each molecule and look what's different. Ooh, oxygen minus side, sodium cation. By the way, if you notice, Dr. White has a habit of always circling negative charges. I never circle positive charge. Why? I don't know. But anyways, ooh, carbon, oxygen, negative charge, sodium cation. You can use other cations, most people. What's there? What's different? What's that carbon? What's that hydrogen? Carbon, carbon, carbon. Ooh, iodine. This is an alkyl halide. And they're different, so that's why I use R prime, this right here. And remember, X can be chlorine, fluorine, well, not fluorine, chlorine, bromine, or iodine. And what happens is this attacks and bonds to the carbon with the halogen. And you get an ether. Now you also get sodium halide, but I'm asking just for the organic. If you want to put this down because it helps you, that's fine. What's R? Methyl. What's R prime? And propyl. Therefore, I have methyl. Then which carbon has the halogen? This carbon right there. Ooh, look how I'm getting fancy on you. going full color. And therefore, that's the carbon that's bonded to the N-propyl group right here. And notice it's an N-propyl group right here. So you got methyl N-propyl ether, N-propyl methyl ether. And that's how you make ethers. There's another way, but this is the best way and the way I'll teach you in class. And you should know this for obviously test 2. Your turn. Have some fun. What would be the organic product or products for the following? And when you're done, one person already has, give me a thumbs up. Looks like everybody's just about giving thumbs up. So I'll give you another 10 seconds. Time's up. Look at how do we determine whether a product or organic product or products? You look at each molecule, what's different, what's not carbon, what's not hydrogen, should get your attention like that. Ooh, oxygen with a minus charge, sodium cation, carbon's here, and this is called an alkoxide, which I'll never ask you on a test. Oh, what do we have here? Ooh, a halogen of carbons. This is an alkyl halide. Remember, X can be chlorine, bromine, or iodine. What happens? This attacks the carbon with the halogen. There's only one. Kicks out the halide as an anion with sodium plus. You get a salt, but that's not what I'm interested in. What's our, well, first of all, let me finish up here. And you get an ether plus salt, but we're interested in the organic. Therefore, what's our ethyl? What's our prime? Methyl. Let me move this all the way over here. And the answer is ethyl, oxygen, methyl, and therefore you've just made methyl ethyl ether or ethyl methyl ether. And if I look at the clock, it's time to take a break. So take 5, I'm gonna do some stretching. We'll come back, we'll do about 45 minutes or so, 50 minutes, including the lab. Don't forget to bring your nose for today's lab. And I'll see you in 5. All right, let's get back to work. Let me call you back to class. I love that. You're probably giving me, he's nuts again. Well, I'm having fun. Hopefully you are. All right, let's get back to class. I just checked my mail too. I put a glove on both hands so I don't have to worry about anything, and I have a way of segregating it. But an interesting note, I've never seen one before, at least I can't remember one now. In the Christmas time, yes, there's actually a Walmart catalog. I guess they're working for business too. All right, we're talking about ethers, and we're talking about the Williamson ether synthesis. Remember, Williamson ether synthesis, an alkoxide plus an alkyl halide ether. Now, let's go to the fun part of organic chemistry, and that's called synthesis. And the question is, and on test 2 and test 1, you'll see later today there's only one. On test 2, usually I put 2 or 3 because you've lost your rookie status. And the question is, how do you do synthesis with ethers? And if we look at this, and on a test, I'm going to be nice. When I took it, we didn't get this, but I will. And this tells you you react two things together, two question marks, and you make this compound. And this would be and the question would be 4 points each. And like I said, I only give a couple, give the starting materials for the following. I could actually make it even higher, say 6 points each. So what do we do? Well, you start and look at the product. What's different? What's not carbon? What's not hydrogen? What's not a carbon-carbon single, but oxygen? Carbon's this side, carbon's this side. It's an ether. And notice Dr. White gave you, which is quite unusual, an inorganic molecule, which is a salt, NaX, where X can be chlorine, bromine, or iodine. How do you make ethers? Alkyl halide plus, or alkoxide plus alkyl halide. And this attacks here, and you form an ether. So I can call this R, and I'll call this right here R prime. If I do that, what's R? Methyl. And I'll have my alkoxide. By the way, the carbon the oxygen is attached to on your R group is the carbon the alkoxide will be attached to also. And what's R prime? Ethyl. Which carbon has the oxygen will have the halogen. Well, in this case, doesn't matter because you have two carbons. So this will always, what's the alkyl group? Ooh, right here, if we look under sodium chloride, that's my X. And if I react it, sure enough, I'll get that ether. But wait, and here's the fun and exciting part sometimes of synthesis. What if I call this R prime and this R? And you can. So then what would be the starting materials then? And here, what's R? It's ethyl. It's an alkoxide. And then what's our prime? Methyl. And what's the halogen? Chlorine still. And both of these would give you this molecule. And the question is, which is right and which is wrong? And the answer to that question is, they're both correct for my class. Either this one or this one on a test would be a correct answer. Now, at my level, and more specifically with my experience, I know this one in red will cost less. How? Because Dr. White's done cost accounting and knows the price of chemicals, lots of them. And at ECC, I'm probably one of only two of the chemists in the whole chem department who would know that. At COD, College of DuPage, I teach at, I don't think any of the other chemists who worked in industry would know that or worked in academics. And that's because I know cost accounting. You don't, and I don't expect you. In fact, one of my biggest regrets coming out of graduate school that I learned real quick when I got to management in chemical industry was I never took at least one accounting class. Who needs accounting? You're going to be a chemist. Well, when you get into business and you're a senior manager and you're in with the president and the vice president of marketing and sales, and your boss is the vice president of research and development, and someone says, well, what's the gross margin on that? Well, guess what? I went out and bought a good accounting book from my accountant, told me, and I read it quick, and I learned out real quick what are those things. All right. Your turn. What would be the two starting materials you react to make this compound, organic compound right here? Have fun. And when you're done, give me a thumbs up. I can give you some time. Take your time because now we're getting into some more challenging stuff. But you can do it. I have faith in you. And when you're done, give me a thumbs up, but take your time. Sorry about that. Wrong, not wrong number. Junk phone call or robocall. All right, I think everybody's done. Anybody need more time? All right, let's do this. How do we do this? We look at the product and say what's different. What's not a carbon-carbon single bond and what's not carbon or hydrogen. Ooh, an oxygen with carbons here and here. This is an ether. Oh, look, something else, an inorganic, a salt. Remember, X can be chlorine, bromine, or iodine. In this case, it's bromine. And how do we make an ether? Williamson ether synthesis. Remember, the oxygen attacks to carbon with the halogen on it and bonds to that. The oxygen here on R is what the oxygen still bond here. So if I come over here, I'm going to call this R, this whole thing right here, and this R prime. If I do that, R is an isopropyl. I have my alkoxide. By the way, if you just want to put O, Na, and no charges, go right ahead. I had a student who successfully argued either way is correct, and he was right. So I liked putting charges. What's my R prime, ethyl? What's my halogen, bromine? There's another answer you could also have used. I'll call this R prime, and I'll call this R. If I do that, R is ethyl. I have my alkoxide. Now here you got to be careful. Which carbon is this oxygen bonded to? The center of 3. And that's the carbon the halogen will be bonded to, which in this case is an isopropyl. What's my halogen? Still bromine. So you could either use answer A or B, the top or bottom one. Which one is correct? They're both correct. And that's how you do synthesis. By the way, that's the fun part of organic chemistry. Psst, you've been doing synthesis, and that's tough organic chemistry. You should feel good about yourself. See, organic chemistry isn't that bad. It's fun. If I say that enough times, you'll believe me, but actually it's true. All right. And that's the Williamson ether synthesis. And it's time for a new functional group. And this new functional group is called the epoxide. And I have it written there, but a better way, let's just think about it. Hold on. Is the simplest epoxide is this, and this is a 2. At first glance, you say, oh, that's a 3-membered ring, that's an ether. But the answer is no. The chemistry of this compound is much different than ethers. Ethers will not react with water. This stuff reacts immediately with water. In fact, violently with water if you're not careful. and therefore it has new chemistry. And these are called epoxides. How many of you have ever heard of epoxy coatings? And they're made with epoxides. The word epoxy comes from epoxide. And I won't get into this now. Later on, when I get into polymers, I'll talk a little about it. Now, I'm not going to go into the nomenclature of epoxides, but I will mention one epoxide. I won't ask you to learn it, but I will ask you to be familiar with the name because I'm going to use it. And the epoxide I'm going to do is the one I already wrote, but I'll write it again. And this is called ethylene oxide, the simplest epoxide. Dr. White's worked with that heavily in industry. And this is a very dangerous compound. It's extremely explosive if you're not careful. If you get oxygen in there, it can blow up. And I worked at 2 plants where they had storage of over 1 million pounds. Quick story. Oh, I do. Quick story. I worked for this one company by Great American Gurnee. And then it was called the Mazer plant, the PPG, Pittsburgh Plate and Glass. And on site, we had about 500,000 pounds of ethylene oxide stored for reactions we did. And in Gurnee, we were about, I don't know, 4 or 5 miles northeast of Great America. And one afternoon, a bunch of us were sitting around in the lab, and someone brought up the fact, because right next to the lab was a plant, what happens if our ethylene oxide tanks blow up? And the question is, would we take out Great America or not? Because we knew if they blew up, we'd be dead like that, because there'd be a crater at least 1,000 feet in diameter from those tanks, if not larger, and we'd be gone. It never happened, still hasn't, and we finally considered the distances and some of the physics involved and the explosive and figured it wouldn't kill anybody, but it would damage Great America and might injure a bunch of people there, the shock wave from the explosion those many miles away. So ethylene oxide is dangerous stuff. First time at another company when I also used ethylene oxide, when I did one myself, I was a little unsure, a little nervous, got religion real quick, and then realized, relax, just take your time, you know it's safe, and I survived. Thank you, you're welcome. Oh, by the way, Dr. White's going to try and be a good chemist and a good teacher in industry. We don't even call it ethylene oxide, we call it EO, short for ethylene oxide. Now, next slide switches off. Why don't you want to have water around? Because ethylene oxide reacts with water to give you this diol called ethylene glycol, di-2-OL alcohol. And what happens is this bond is so constrained, it breaks like that in the presence of water. The H goes here, and the hydroxyl group goes here. And that's how you form this. So whenever you work with ethylene oxide, you want to make sure it's scrupulously dry. I mean, like completely. Well, let's talk about an important reaction of ethylene oxide, and that's with alcohols. And this is extremely important. And for those who use hand creams or other personal care items, some of these products in there are made from this reaction. Let's rewrite it a different way. You take an alcohol, react it with ethylene oxide, the H goes to the oxygen, you break this bond, and this goes on that carbon. Or the other one, they're both identical. And you form this molecule. And notice this molecule has, yes, not one, but two functional groups. Here I have carbons, oxygen carbons. I have an ether. Here I have carbons hydroxyl group. I have an alcohol. And in industry and nature, Mother Nature likes to do this a lot. When we get into fats and oils, carbohydrates and proteins, you'll see that. But for now, I'm going to stay away from it, except for this example and a couple others. But anyways, you have an ether alcohol. Let's look at some of the chemistry of ethylene oxide with alcohols. Let's start out with a simple one. What's the organic product or products? 3 points each. What do we have here? What's different? Ooh, an alcohol. What's this? An epoxide, ethylene oxide. What do you get? An ether alcohol. And if we look here, what's our, ooh, that changed on me without me doing anything. That's strange. Say Friday the 13th, it's not even Friday. And what is our methyl? So I have this. I have my oxygen, the rest of the molecule, which I write down. And this is called epoxidation or ethoxylation. I'm sorry, ethoxylation. Why don't you try one? What would be the product or products for following reaction? Go. Now we're getting into the good stuff. I'll mention it in my email, but I'll mention it now. Later today and tomorrow morning, because I have to teach in the morning from 10 to 12:30 or almost 1 o'clock. I will, before that tomorrow morning, the rest of the day, about every 2 hours or so, I'll be checking my email. Plus tonight I have my office hours. If you have any questions about tests, always feel free to ask. If we were in a classroom, I'd tell you the same thing. Remember, there's no such thing as a dumb question, and you can ask questions during a test. Now, what I won't do is give you the answers to the questions, but I'll answer any confusion you might have about what the question is asking. All right, let's get back to work. What's the organic product or products for the following? We look here and we say, oh, what's different? What's not carbon? What's not oxygen, hydrogen, and a carbon? This is an alcohol. What's this? Ethylene oxide. What do you get? This ether alcohol. What's my R group? Isopropyl. Therefore, you don't break carbon-carbon single bonds. You know that. I have my isopropyl group R. The carbon with the hydroxyl group here will be the carbon with the oxygen. Then I have CH2, CH2, OH. Now, these are tricky reactions in terms of synthesis. Therefore, on the test and my final, this reaction will never be in a synthesis reaction. And you have my word on that. Dr. White doesn't break his word. Oh, let's do another one. These are fun. And why don't you try this? What would be the organic product or products for the following reaction? And when I was at Mazer PPG, we did this reaction or similar ones, lots of them, millions of pounds a week. By the way, I don't have time today, but someone next week remind me at the end of the lecture to tell you a real, this sort of story about when I was working at that company. It involves the last name I think you might be familiar with, Dahmer. How many of you have heard that name? Like in Jeffrey Dahmer? I'll tell you the story. I don't have time today. Oh, I just did a cliffhanger on you guys. All right, let's do this. Question is, what's the organic product or products for the following? Ooh, what's different here? Oxygen, hydrogen, and a carbon here. This is an alcohol. Ethylene oxide here. And what do you get? This ether alcohol. What's my R group? N-butyl. Remember, the carbon with the hydroxyl group is the carbon this oxygen is bonded to. So 1, 2, 3, 4, O, CH2, CH2. Just fit it in. I'll put in my hydrogens because you know there are 4 bonds to carbon. Now, this molecule you made has a name, and the name is 2-butoxyethanol, or also known as this butoxyethanol. And one of the things I started last time, and I'll be doing more and more, and now is the time to do it, is why am I learning this stuff? What good is it to me? Well, the obvious answer is you want to get into a program or school that requires you to take Chem 170. You want to get a good grade. But why learn about this stuff? Well, let's find out. Someone asked, am I still having normal office hours tonight? And the answer is yes, I am. Every Monday and Wednesday, unless somebody gives me $1 billion, and don't hold your breath on that, I will have the semester my office hours. Or if I lose internet, that happened a couple weeks ago during the day for my other class. All right, let's find out. Why are you learning this? All right, this molecule right here, butoxyethanol. First of all, if you go to your local supermarket and buy a really good product that works well, and that's the cold, not the hot one, but the cold oven, easy off oven cleaner, the main ingredient that gets your oven clean when it's cold, you spray it on there, is this molecule. If you look at the label, you'll see that. And that's what's in there. Now, I would caution you, and I've done this for my sister for her oven, wear gloves and I wear safety glasses just to be on the safe side. And also I make sure the windows are open in the kitchen so you have good ventilation. I put a fan to make sure if there's no wind that day, we get good air current. Because it turns out this compound is hazardous. How hazardous? Well, true story. Well, I don't have any false stories, so I don't know why I always say true story. But anyways, how many of you have heard of the Deep Horizon oil spill? In case you forgot, a little history. What year was it? In August of 2010, in the Gulf of Mexico, on an oil well platform called Deepwater Horizon, they had an explosion. It caused serious damage, and the backup emergency valves didn't function, and millions of gallons, multi-million pounds of crude oil were just dumped right into the Gulf of Mexico. And this caused tremendous environmental hazards. Now, at that time, Dr. White, still being an organic chemist, and I always will be, I was listening to news and someone said, oh, they're using this product to disperse the oil called Corex, and Corexit, and it was made by a chemical company in Naperville. And knowing organic chemistry, and I'm going to teach you a lesson now, when you see a product, you can look up what's called the material safety data sheet on the internet by putting the name of the product. And I've already done this. Well, let's see, I thought I had it. All right, everybody see the thing, Nalco on the screen in the upper corner? Can you see that? Thank you. And if you look at the material safety data sheet, they're always the same. I've actually written some for molecules I've invented for companies I worked at. The second set part, first is its name and who makes it. And notice it's Nalco. They're now owned by a French company, and it's Nalco division. I forgot the name of the French company. You'll see that it contains 2-butoxyethanol, anywhere from 30 to 60%. Which means if I'm dumping millions of pounds of this product into the Gulf of Mexico, I'm dumping this much butoxyethanol. So what did Dr. White do? He looked up the MSDS sheet for butoxyethanol. And here's one company, Fisher's, and here's another name for it. Notice the synonym, 2-butoxyethanol. And if you look down here, it's pretty toxic. And this is a newer MSDS, the older one from 2010. Dr. White's going to sneeze in a second. Excuse me. If you come down exposure, when you see where they have permissible exposure limits in ppm, you know it's really hazardous. If you scroll down further, you'll see toxicological information. And over here, you see LC50. That's the lethal concentration that kills 50% of whatever animal they're testing. And here, 450 ppm will kill a rat in 4 hours, half the rat population. And another one was similar, another study. And it has serious effects on your skin, and it's quite hazardous. Now, with this one, I don't think it has. Here's what happens if you're exposed to it and inhale it. And we come down here, I can't find it right now, but the older MSDS one I looked up in 2010 gave all sorts of carcinogen, destroys your certain organs, mutagen. It's dangerous stuff. So Dr. White, who's been raised by my parents as being a socially responsible person, and now you're looking at a socially responsible organic chemist, I immediately got in contact with the Coast Guard, who was in charge of the cleanup. And I finally got to the number 2 guy. I didn't get to the head person in charge. And he said, well, you talk to this chemist who's in charge for us. And it turned out it was an analytical chemist who was from academics, no industrial. And he said, oh, it's not that. I said, this is dangerous. And I got back to the second man. Well, if the chemist says that, well, it's not that bad. And Dr. White doesn't stop then. At that point, I contacted the New York Times, MSNBC, and CBS and let them know. Now, was I the only chemist who did that? I don't know. But within about a couple hours, those news organizations were looking into it and finding out it was very toxic. And if you know the history, it killed a lot of fishing, not only oil, but that dispersant did. And about 2 or 3 years ago, and this is a sad story, through certain things that happened, a person who was on one of the cleanup teams that were volunteers cleaning up the beaches and saving wildlife. If you remember back then, you saw Dawn being used to clean birds and the oil off them so they wouldn't die, which it worked quite well. I'll teach about soap later on. Well, anyways, that person became a reporter and did a lot of exposés on that. And a couple of years ago, which is about 7 years later, someone told him about me and what I had done, and he contacted me. I talked to him, and we talked about it, and he said, he just did a follow-up he was going to do on the people who were exposed, and what's in the MSDS sheet, which you brought to the authorities' attention, is stuff people are suffering right now, 7, 8 years later, exposure to that chemical. So what does that mean? Some chemicals are good, some chemicals, well, they're dangerous. And thank you, Angela. But that's some of the things I've done in my life. If I see something dangerous, get the word out, because of my training, I know it is. And that's not the only time I've gotten the word out on stuff dangerous. But let's get back. And now you know that here you can make a molecule with a reaction, and it's used in our commercial, our daily life. Some uses are good, cleaning your oven. Some uses are clearly bad, used as an oil dispersant. How am I doing time-wise? All right. It's time for the lab. Get your safety goggles on. Don't forget to put your gloves on, get your lab coat on. It's time for the lab. Today's lab, you're going to need a very sensitive analytical piece of equipment, your nose. And let's look at today's lab. Don't forget to hand in the lab that's due today. Upload it. Everybody see Aromatic Compounds Lab on the screen? Thank you. All right. Now, I've talked about aromatic compounds, and they play an important role in our life. Now, they're found in many spices and herbs. I just put down spices. And throughout the 1400s to the 1700s, wars were fought over control of these spices and the lands where they were grown. Huge fortunes were made on the sale of these. Now, spices and certain plant extracts have a common chemical feature. They contain a benzene ring, which is, as you know, aromatic. So that's why these are called aromatic, because they come from things with a benzene ring, things that have a very strong odor to them, aroma. And some of these can found, and the chemical names are this. In this lab, you'll be using, like I said, an important sensitive analytical instrument, your nose, to smell some spices and a chemical that comes from plants. And you'll be asked to record your odor observations. Unfortunately, we're not in the lab because of COVID-19. The fact that I was able to pull off, I'm doing it now to keep you safe and you don't have to go to ECC, which luckily they're still safe there, but I think you find it safer in your home than there. Now, the things you'll be smelling if you were in the lab, and if you have this at home, take time and smell it, are cinnamon, cloves, nutmeg, vanillin, like in vanilla extract. Actually, I have the molecule vanillin. Hold on one second. I almost forgot to bring it in. Let me see if I can find it. Hang in there. Vanillin. It's a solid. Oh, I love it. Dr. White is a vanilla extract freak. I love it. I love it in frosting. I love it in ice cream. I love it in, how many of you are familiar with cream soda? Also old name used to be vanilla phosphate. Oh, I go nuts over that stuff. But anyways, this is what comes from the vanilla bean. And what you buy is dissolve this compound and some other compounds too in water and ethanol to make a homogeneous solution. Now, what you would be doing is smelling the stuff. We'd all be in a little group in the lab, and I'd be passing it around, and you get to smell it. And afterward, you can smell it more. Now, I've put in a couple things in case you're not familiar, and then you can put down what you think. Now, I'll tell you another story later in the semester, but one of the hardest problems I ever had to face was what was called the product you're making now smells bad compared to your competitor. I had to learn real quick about odor panels and everything else. And this was for at that company, a big company, and we had about $60 million a year in sales on the line if I didn't solve that problem. But I learned a lot about smelling. And what I perceive an odor and what you perceive are going to be two different things based on your background, your life experiences. So when I ask you to put down the odor of something, there's no right or wrong answer. Well, there would be. If you tell me it smells like the surface of the moon, I might mark that wrong because you're going to be in a spacesuit anyway, so you're not going to smell anything out there, at least the surface. But one of the things I put in that students have told me for cloves, Christmas ham, Dr. White would say it reminds me of a dentist's office, and I'll explain that in a second. Nutmeg, vanilla, cinnamon, nutmeg, vanillin, and benzaldehyde. Now, benzaldehyde is a chemical I'll teach you later on, but you're going to have to look up the structure yourself. And whenever you smell maraschino cherries, I do, I think of benzaldehyde. I'm a Dr. Pepper freak too, it reminds me. And almonds and almond mascarpone are all things that remind me of benzaldehyde. If we were in the lab now, I'd be passing around some paper towels that I just put benzaldehyde, a liquid at room temperature, on, and you smell it. And you go, cherries. No, almonds. Actually, I can smell it and I can smell both. And it matters how your brain's wired. I guess mine's wired quite interestingly, and I'll leave it at that. But you would smell that. Now, for today's write-up, put in what you think these smell like. And here are the questions. Now, in question 2, I'm asking you to draw the structure of the key aromatic or aromatic chemical found in spices and aromatic chemicals that you tested. Now, to help you out, and I do this in the class too if we're in the lab, close the key chemicals eugenol. Now, if you're not sure how to look up a chemical on the internet, go to your favorite search engine. Mine is Google. By the way, I rarely use the word Google as a verb. I used to use it as a noun, and put in the name of the chemical like eugenol and put in structure. And sometimes put in structure in wiki so you can get to Wikipedia and you'll find it. In cinnamon, which I like, my older sister hates with a passion. I don't know why, I like it. But anyways, the chemical is trans-cinnamic. Yeah, oh, you know what trans means. In nutmeg, it's isoeugenol. For vanilla extract, put in the chemical vanilla or name vanillin. And for benzaldehyde, just put in benzaldehyde. Now, if you look up here, dentist's office, closed. Why is that? I'll explain. Unfortunately, in my family, bad dental problems are hereditary, and I unfortunately didn't miss the boat on that. And so if you've ever had injections, ouch, from the dentist, if you go to a good dentist, and I've had some good ones, I've had some not so good ones, what will they do? Before they inject you with the whatever anesthetic they're going to use to get the nerves numbed, they'll wipe something on your gum. And what they're wiping is oil of cloves. And the oil from the cloves, which has eugenol, will numb your skin, the surface, briefly, long enough that they can go, ouch, inject you so you don't feel the needle, which one doctor was real good at. I couldn't feel when he did it at all. He was that good dentist. I mean, a great dentist too. Raleigh Rudnick, he was the dentist who did the identification for the DC-10 crash in O'Hara. He told me some stories about that. Anyways, not a fun job for him. He was one of the few certified dentists in the United States who would do that at that time. But anyways, so whenever I smell that, I think of that from clothes from my dentist's office. So that's today's lab. I said I'd get you out early today. I will. In about 10 minutes or so, I'll be emailing out the email with the password. I will have my normal office hours. Now listen carefully. I promise by 1 p.m. Sunday, probably a lot sooner, but definitely by 1 p.m. Sunday, I will have in D2L your test scores. I will also have mailed out to you individually, personally, the points for each answer you put on test number 1. And this is something I do, and I will. It means if I get something gets me sidetracked on Friday or Saturday night, I don't go to bed until I get those graded, so I can get them out to you in the morning. So with that, I'm going to say Don't forget, take test number 1, get it uploaded to me as a single PDF file by tomorrow. There's instructions how to do that in case you haven't learned how to do that. And if you have any questions, email me. I'll check it about every couple hours today and tomorrow morning, or come to my office hour tonight. And with that, goodbye, gang gesund. Good luck on test number 1. Hopefully you won't need test number 1. And remember, for test number 1, no, you don't break carbon-carbon single bonds and 4 bonds to carbon. With that, I'll say goodbye. I'll see you on Monday. Have a nice rest of the week and weekend.